Hello everyone, this is about the round robin CPU scheduling. Are you ready to learn? The categories are round robin, advantage and disadvantage of RR scheduling, example programs of RR scheduling. What is round robin? A round robin that assigns each process a fixed time slot in a cyclic manner. As a core, this is the most commonly used techniques in CPU scheduling. This is the advantage and disadvantage of round robin scheduling. This is the advantages of RR scheduling. There is a fairness because each process equal receive an equal shares of the CPU. The newly created process is moved to the bottom of the ready queue. A round-robin scheduler typically uses time sharing, assigning time slot or quantum to each job. A specific time quantum is allotted to different jobs during round-robin scheduling. And lastly, in this scheduling, each process has a task rescheduled after a specific quantum time. This is the disadvantage of RR scheduling. There is a longer wait time and a faster response time. There is a low throughput. There is a context switches. The Gantt chart appears to be too large. If quantum time is less for scheduling, for example, 1 ms for big scheduling, time-consuming scheduling for small quantums. How to compute times in round-robin using a program. Number 1 is the completion time. The time it takes for a process to complete its execution. Number 2, turnaround time. The time difference between completion and arrival. Turnaround time equals completion time minus arrival time. The next one is the waiting time. The time between the turnaround time and the burst time. Waiting time is equal to turnaround time minus burst time. In this post, we have assumed arrival time as 0. So turnaround and completion time are same. The tricky part is to compute waiting time. Once waiting time are computed, turnaround times can be quickly computed. And this is the step to find waiting time of all processes. This step number 1. Create an array rem underscore bt square bracket to keep track of remaining burst time of the process. This process initially a copy of bt square bracket or burst time array. Step number 2. Create another array wt or waiting time square bracket. To store waiting time of process, initialize this array as 0. Step number 3. Initialize complete time. ct or complete time is equal to 0. And lastly, step number 4. Transversing the all processes while all the processes are not done. Do following for ith process if it is not done yet. If rem underscore burst time square bracket I square bracket greater than quantum, the first I is the complete time equals complete time plus quantum. The second I is the rem underscore bt square bracket I and the square bracket is equal to quantum. In letter B, the else, the last cycle of this process. The first I is the complete time is equal to complete time plus rem underscore bt open close bracket with I with a semicolon. The second I is the waiting time open close bracket with the I and equals to complete time minus bt open close bracket with I and semicolon. And the second I also, rem underscore bt open close bracket with I inside is equal to 0 and semicolon. Watch the tutorial for CPU scheduling of round robin.
into the kitchen, you saw the look on my face. You saw the look on my heart to get out of this place. I seen something I've never seen before. When you put on the pineapple, we couldn't be friends anymore. Pineapple thousands, go on pizza. It's a fruit and you know that. Pineapple doesn't go on pizza. They just don't belong. When I walk into the kitchen, you saw the look on my face. You saw the look on my heart to get out of this place. I seen something I've never seen before. When you put on the pineapple, we couldn't be friends anymore. Pineapple thousands, go on pizza. It's a fruit and you know that. Pineapple doesn't go on pizza. They just don't belong. pretend